Chemistry is the study of chemical reactions. If there are no chemical reactions, then there is no chemistry. Chemical reactions are the assets of chemistry. In class 10th, you have studied about chemical reactions and chemical equations, right? So first let us try to understand what is meant by a chemical reaction. Let us consider a reaction where carbon burns in the presence of air to form carbon dioxide. A chemical reaction means transformation of one substance into another substance. There are many ways in which you can define a chemical reaction. This is one of the simplest way of defining a chemical reaction. That is transformation of one substance into another substance. The substances that take part in the chemical reactions are called as reactants, and the substance that is formed after the chemical reactions are called as products. In this reaction, carbon and oxygen are called the reactants, and carbon dioxide that is formed is called as the product. By studying various chemical reactions, it was observed that all the chemical reactions will take place according to certain laws, and these laws which governs the chemical reactions are called as laws of chemical combination. There are many laws, but in the NCERT textbook few laws have been discussed, and here we are going to discuss only those few laws which are given in the textbook. Okay, the first law of chemical combination is law of conservation of mass. Law of conservation of mass states that in any physical or chemical change, the total mass of the reactant is equal to the total mass of the products. For example, let us take the same reaction. Here, the gram atomic mass of carbon is 12 gram. The gram atomic mass of one oxygen atom is 16. Here we have two oxygen atoms, so 16 into 12, that is 32. So now, what is the total mass of the reactant? 12 plus 32, that is equal to 44 gram. Now, let us take the mass of carbon dioxide that is formed. We have one carbon atom, that is 12, and we have two oxygen atom, so 32. So 12 plus 32, that is equal to 44 gram. So in all physical and chemical changes, the total mass of the product formed will be equal to the total mass of the reactant. There will be no situations where 1 gram will be extra or 1 gram will be less. Okay, so the total mass of the reactant is equal to total mass of the product. So how you can state the law of conservation of mass? Law of conservation of mass states that in all physical and chemical changes, the total mass of the product is equal to the total mass of the reactant. Is this clear? Okay. The second law is law of constant composition or law of definite proportion. Let us try to understand this law by taking an example. Let us collect water from different sources. Let me assume that this is the water that I have collected from tap, and this is the sample of water that I have collected from river, and this is another sample of water that I have collected from well. Now you see, all these are the water samples that I have collected from different sources, but all these water contains same element, that is hydrogen, oxygen, hydrogen, oxygen, hydrogen, oxygen, and that too they have combined in the same ratio 1 is to 8, 1 is to 8, 1 is to 8. Now let us put all of them in the form of a sentence. That will become the law of constant composition. Law of constant composition or law of definite proportion states that pure chemical compounds contains same elements combined in a definite ratio by mass irrespective of the source. All the pure chemical compounds consists of same elements combined in a definite ratio by mass. This is called the law of constant composition. So once again I will repeat. The law of constant composition states that pure chemical compounds contains same elements combined in a definite proportion by mass irrespective of the source. Let us take one more example. Carbon dioxide, which is obtained from different sources, or let us take the carbon dioxide that is prepared by different methods. You can obtain carbon dioxide by burning carbon or by heating limestone. All this carbon dioxide which is obtained from different methods will contain same elements combined in a same ratio by mass. See, they contain carbon and oxygen combined in the ratio 3:8. Okay, next, third law is law of multiple proportion. This law is applicable only when two elements combine to form two or more compounds. Here let us take carbon and oxygen. This carbon and oxygen combines to give carbon monoxide, and the same carbon and oxygen will combine to give carbon dioxide. See, two elements combine to give two or more compounds. Only when two elements combine to give two or more compounds, law of multiple proportion must be used. Now, in carbon monoxide, we have one carbon atom and one oxygen atom. So the gram atomic mass of carbon is 12 and that of oxygen is 16 gram. In carbon dioxide, we have one carbon atom and we have two oxygen atom. Therefore, the mass is 32 gram. Now you see here the mass of carbon is fixed. In both the compound, the mass of carbon is 12 gram, 12 gram. But the mass of oxygen is different. Let us take the ratio of the different masses of oxygen, that is 16:32. If you simplify this, you will get 1:2. Carbon mass is fixed. The oxygen mass is not fixed. If you take the ratio of the mass of oxygen, the ratio will be a simple whole number. See, 1:2. It will be always a simple whole number. It will be not like 1.1:2.1. You will definitely will not get any ratios. It will be always a whole number. Now let us put all of them together and we'll make a sentence. So we get law of multiple proportion. So law of multiple proportion states that when two elements combines to form two or more compounds, the masses of one element that combine with fixed mass of another element will always bear a simple whole number ratio. Once again I will repeat. When two elements combine to form two or more compounds, the masses of one element that combine with fixed mass of another element will always bear a simple whole number ratio. Is this clear? Okay. Next, fourth law is Gay-Lussac's law of combining volume. Gay-Lussac's law of combining volume. This law is applicable only when gases combine to form the compounds. When gases combine to give the compounds or to give the products, we use the law of combining volume. So the Gay-Lussac's law of combining volume states that under similar conditions of temperature and pressure, when gases combine, whenever gases combine, they do so in a simple whole number ratio by volume. That is, whenever gases combine to give some product, they always combine in a simple whole number ratio by volume. You see, in this case we have 1 mole of nitrogen gas and 3 mole of hydrogen gas. You take the ratio. See, the ratio is a simple whole number. That is, whenever gases combine, they always combine in a simple whole number ratio by volume. In this example, nitrogen and hydrogen combines in the ratio 1:3 by volume. What does it mean? It means that 1 liter of nitrogen gas combines with 3 liter of hydrogen gas to form 2 liter of ammonia gas. It is not 1 kg of nitrogen combined with 3 kg of hydrogen. No. 1 liter of nitrogen combines with 3 liter of hydrogen. That is why I mentioned they always combine in a simple whole number ratio by volume. So Gay-Lussac's law of combining volume is applicable only when gases combine to give some product. So it states that under similar conditions of temperature and pressure, whenever gases combine, they always combine in a simple whole number ratio by volume. I'll repeat once again. Under similar conditions of temperature and pressure, whenever gases combine, they always combine in a simple whole number ratio by volume. Is it clear? Fine. The last law is Avogadros Law. If we consider two different gases, let us take nitrogen gas and hydrogen gas. These are the different gases that I have considered. Let the volume of both of these gas be same. Let us say I took 10 cm cube of nitrogen and 10 cm cube of hydrogen, equal volume, and the temperature of both of these gases are same and pressure is also same. Volume is equal, temperature is same, pressure is same, then both of these gases will have equal number of molecules. That is what is Avogadros law. Under similar conditions of temperature and pressure, equal volume of gases contains equal number of molecules. If let us assume that I took 10 cm cube of nitrogen gas, 10 cm cube of hydrogen gas, the temperature and pressure of both nitrogen and hydrogen is equal, and in nitrogen gas there are 100 nitrogen molecules. Then since the volume is same, temperature is same, hydrogen also contains 100 hydrogen molecules. Avogadros law or Avogadros hypothesis states that under similar conditions of temperature and pressure, equal volume of all gases contains equal number of molecules. Okay, so these are the 5 laws of chemical combination. After studying all these 5 laws, next comes Dalton Atomic Theory. John Dalton was a very intelligent and brilliant scientist who lived in 19th century. All of his life he has done research just to find out what is this matter made up of. What is that fundamental particle which builds up the matter? We have learned that matter is anything which has mass and occupies space, and everything that we see in and around us are matter. But what is this matter actually made up of? So this is what John Dalton was interested to know. So, and he has spent whole his life doing researches regarding this. And after studying all these 5 laws of chemical combination, finally he proposed his theory called as Dalton's atomic theory. So what are the main points of his theory? And all these main points of his theory are called as the postulates. So let us study the postulates of Dalton's atomic theory. The first postulate is, he says, every matter is made up of very tiny particles called atoms. So everything that we are seeing in and around us are matter. And what is this matter made up of? They are made up of a very small particles, invisible and indivisible particle called atoms. So you should not write so lengthy postulates. In a simple way, this is how you must write. That is, every matter is made up of tiny particles called atoms. The second postulate is, atoms can neither be created nor be destroyed. Atom can neither be created nor be destroyed. Third postulate is, atoms of a given element. Let us take an hydrogen element. We know hydrogen element is made up of hydrogen atoms. So let us take the hydrogen atoms of hydrogen element. So atoms of a given element are identical in properties. That is, if you take the atoms of same element, all these atoms will have same shape and same size and same chemical properties. That is, they are identical in properties. What is the third postulate? Atoms of given element are identical in properties. Fourth postulate is, let us take hydrogen element and oxygen element. Let me assume that this is the hydrogen atom and this is the oxygen atom. Atoms of different elements will have different properties. Atoms of different elements will have different properties. That is, they will have different shape, they will have different size and different chemical properties. Is this clear? The last postulate is, atoms of different elements combine in a definite ratio by mass to form compounds. So fifth postulate is, atoms of different elements, they combine in a fixed ratio by mass to form compounds. So these are the 5 postulates of Dalton's atomic theory. Once again I will recall. First, the first postulate, every matter is made up of tiny particles called atoms. Second one, atoms can neither be created nor be destroyed. Third one, atoms of given element will have same properties, identical properties. Fourth one, atoms of different elements will have different properties. Last one, atoms of different elements combine in a definite proportion by mass to form compounds. So these are the five postulates of Dalton's atomic theory. Okay, and John Dalton was the first person to put forward a theory for atom, and it's called as Dalton's atomic theory. Hope you understood all these concepts. So this is all for this class. In the next class we are going to study a very important concept called atomic mass and molecular mass. Okay.